Welcome to Module 5 of Essential Python Scripting for GIS. This week, we'll look at geoprocessing with Python. In the last module, we talked about how we can use Model Builder and batch processing to streamline and even, to a certain extent, automate common geoprocessing steps. As a GIS professional, if you do any amount of geoprocessing, you will want to make use of these approaches. This module will delve more into how you can automate geoprocessing with Python. In Python, reusable code is distributed in so-called modules and packages. Arcpy is a site package used to create the cornerstone for a useful and productive way to perform geographic data analysis, data conversion, data management, and map automation with Python. A module is a Python file that generally includes functions and classes. Arcpy is supported by a series of modules including a data access module, a mapping module, an ArcGIS Spatial Analyst extension module, and an ArcGIS Network Analyst extension module. A class is analogous to an architectural blueprint. The blueprint provides a framework for how to create something. A function is a defined bit of functionality that does a specific task and can be incorporated into a larger program. Let's discuss each of these items in more detail and how they relate to your geoprocessing tasks. At this point, you've used the import Arcpy statement in your lab assignments. Arcpy provides a rich and native Python experience, offering code completion and reference documentation for each function, module, and class. Arcpy provides access to geoprocessing tools as well as additional functions, classes, and modules that allow you to create simple or complex workflows. A geoprocessing tool has a fixed set of parameters that provide the tool with the information it needs for execution. Tools usually have input parameters that define the dataset or datasets that are typically used to generate new output data. Parameters have several important properties. Each parameter expects a specific data type or data types such as a feature class, integer, string, or raster. A parameter expects either an input or output value, and a parameter either requires a value or is optional. Each tool parameter has a unique name. When a tool is used in Python, its parameter values must be correctly set so it can execute when the script is run. Once a valid set of parameter values is provided, the tool is ready to be executed. Parameters are specified as either strings or objects. The advantage of a result object is that you can maintain information about the execution of tools, including messages, parameters, and output. These results can be maintained even after several other tools have been run. Like tools, but more generally, functions are used to do a specific task, such as list datasets or retrieve properties of a dataset. Within Arcpy, all tools are functions, but not all functions are tools. Along these lines, it is interesting to note that there are functions available within the Arcpy environment that aren't available as tools. Also, one distinction that sets functions apart is that they return values. The syntax of a function is Arcpy with the function name and arguments in parentheses. Arguments and parameters are used interchangeably to mean things in which you pass to a particular function. In most cases, these parameters will be things like feature classes, field names, or even numerical values. This example creates a Python list of feature classes using the list feature classes function, then loops through the list, clipping each individual feature class with the boundary feature class. Classes can be used to create objects, often referred as an instance. Arcpy classes such as spatial reference and extent classes are often used as shortcuts to complete geoprocessing tool parameters that would otherwise have a more complicated string equivalent. Arcpy includes several classes including spatial reference, value table, and point. Once instantiated, its properties and methods may be used. In this example, the spatial reference projection file is the class constructor. It creates a spatial reference object by reading a projection file. Like most other classes, spatial reference contains a number of methods and properties, such as name and type. In order to get to the optional parameters within a tool or function, use an empty string or number sign in double quotes. Here we see an example where we are using empty double quotes to get to the optional parameters of the buffer analysis tool. The environment settings are exposed as properties of the env class. To use the properties available in this class within Arcpy, use the syntax arcpy.env. This is of course after you have at least imported the Arcpy site package. If you want to get away from having to prefix the env class with Arcpy, you can use a from import statement such as from Arcpy import env. Here you see how to programmatically set the geoprocessing option to overwrite the outputs of the geoprocessing operations, the same one that you can manually set as shown on the left. This concludes the video about geoprocessing with Python. Please be sure to post any questions you have to the discussion boards and get started on the lab early.